In this problem, a rock climber is at rest on a ledge. Immediately, the phrase "at rest" should set off your physics senses. At rest means that the net force in both the x and y directions are zero. To solve this problem, first find an expression for the x and y components of the net force. The forces at work are a tension in the rope that has both negative x and plus y components, a normal force perpendicular to the wall in the plus x direction, a gravitational force pulling in the negative y direction, and a static frictional force resisting gravity and thus pushing up into the plus y direction. We are given a force vector, which is a contact force that encompasses the normal and static frictional forces. Because we have the angle between these forces, we can calculate them as varying directly with that force vector. We're also given the angle between the components of tension, so we can find Ftx and Fty, the force of tension in the x and y components, as varying directly with the force of tension. We can use the two equations we built, setting F net x equals 0 and F net y equal to 0, to substitute a value for the force vector that exists, and then solve for the force of tension. For part B, we already had the equation for the x component of the net force. By substituting the value that we found for the tension force in the previous problem, we can just use basic algebra to find the force vector of the wall. For part C, the static friction equals mu, the coefficient of friction, times normal force. We found the normal force and static friction forces as components of F, the wall force vector, previously. So by plugging those values into the equation, we can solve for mu fairly simply.